Welcome to section 6.3, solving linear systems by elimination using addition. To solve a linear system using the elimination method, we follow these steps. First, make sure to align the variables in your equation. So make sure you stack them on top of each other. X's over X's, Y's over Y's, constants over constants. Step 2, add or subtract the two equations together to eliminate one of the variables. Step 3, solve the resulting equation for the other variable. And step 4, substitute your answer into one of the two original equations to solve for the second variable. We will go through a couple of these to show you how this is done. So here we have a linear system, x plus 5y equals 9, 4x minus 5y equals negative 14. You should notice that the y variable has a coefficient of 5 in the top equation and negative 5 in the bottom equation. What we can do now is these two equations are stacked on top of each other. The variables are aligned, so we can just add the two equations together. X plus 4x is 5x. 5y minus 5y goes to 0. And 9 minus 14 is negative 5. We then divide by 5 to get the x variable. And we get x is negative 1. We then take one of our two original equations, plug in the x is negative 1, and solve for y. I will use the top equation. We have negative 1 plus 5y equals 9. We're going to add 1 to both sides to move the negative 1 across the equal sign. We get 5y is 10. Divide out the 5. And y equals 2. So my answer is negative 1, 2. That is the ordered pair. That is the solution for this system. All right, so the first one we did, the variables had opposite signs. The y variable had a negative 5 and a 5. So that was really easy. All right, sometimes that doesn't happen. If you look at the set on the left, the system there, we have 5x plus 2y equals 12. And we have 9x plus 2y equals 12. You'll notice that the y variable, each of them has a positive 2. Well, one of the things we can do is we can subtract the two equations from each other. But you have to be careful if you do this. So this is how we do it. We're going to take the bottom equation and we're going to subtract it off. You can distribute the negative through, or just remember that you're subtracting. So 5x minus 9x is negative 4x. 2y minus 2y goes to 0. 12 minus 12 goes to 0. We get negative 4x equals 0. We divide by negative 4. And we get x is 0. And we plug it into either of our two original equations. I'll use the top one. 5 times 0 plus 2y equals 12. That leaves us with 2y is 12. Divide out. And y is 6. So our ordered pair is 0, 6. And this is the solution to our system. Another way to do this, instead of just subtracting off the second equation, is to actually multiply one of the two equations by negative 1. It doesn't matter which one you do. So let's multiply the top equation by negative 1, and then we'll just add them together. So now we have negative 5x minus 2y equals negative 12. And then we have 9x plus 2y equals 12. Now we have opposite signs for the coefficients of y. We have a negative 2 and a positive 2. We can just add these together, these two equations. Negative 5x plus 9x is 4x. Negative 2y plus 2y is 0. Negative 12 plus 12 is 0. And you will see that we will get the same solution as we did on the left. If we plug 0 back in, we'll find out it's 6 for y. You can do either method, but just if you do the method on the left, be very careful that you are subtracting everything. Be careful with your signs. I think for many of you, it'll be easier to multiply one of the equations by negative 1 to get opposite coefficients on one of the variables. But it is up to you what you want to do. You can do either. They are both mathematically sound. So it's your turn to try to solve this system. Please pause the video and see if you can solve this by addition, elimination by addition or subtraction. I am going to subtract off the bottom equation. So we have 7f minus 7f, which is 0. We have g minus a negative 2g, which becomes g plus 2g. And g plus 2g is 3g. Then we have negative 7 minus a negative 31. That becomes negative 7 plus 31. So we get 24. Divide by 3, and you get g is 8. We are then going to pick one of the two equations to plug it into. I'm just going to use the top equation and solve for f. So 7f plus 8 is negative 7. Subtract 8. And when you do this, you get 7f is negative 15. Divide by 7. And f is negative 15 over 7. So if we have to write an ordered pair, we will do this in alphabetical order. Our ordered pair would be negative 15, 7, and g is 8. There is my ordered pair. And that is the solution. Hopefully this is what you got. All right, that is it for solving systems by using the elimination method when we're doing addition or subtraction. The biggest thing when we do elimination by addition or subtraction is we must have one of the variables with the same or opposite coefficients. That's the only way we can do this, because when you combine the two equations, the one variable should go away, leaving just one that you solve for. Thank you for watching, and have a nice day.